So here's what rigid metal conduit looks like. It looks like steel, and then these are plastic coated. And again, on the job site, they might call it Rob Roy, or they might call it Plastibond. There's another name I can't think of right at the moment, but there's another name for it. They're all the same thing. They're just manufactured by different manufacturers. 1.1.4, identifying aluminum conduit. Aluminum conduit resists corrosion better than steel conduit. It's good for use in areas that may be wet or where there are chemicals, such as a sewage treatment plant, around cooling towers, and in food service areas. It's also good for special purposes, such as a high cycle lines, 400 cycles or above, and where there's magnetic induction, such as near MRI equipment in hospitals. According to NEC section 300.6b, aluminum conduit in concrete or in direct contact with the soil must have supplementary corrosion protection. Examples of supplementary protection include paints approved for the purpose, tape wraps approved for the purpose, or PVC coated conduit. The aluminum is lighter than steel. It doesn't afford as good a protection for the conductors inside of it, but it's still fairly decent protection from physical damage. And again, it's not ferrous, it's not magnetic, so it is not susceptible to magnetic interference. Do not bury aluminum conduit in soil or concrete that contains calcium chloride. Calcium chloride may interfere with corrosion resistance of aluminum conduit. Calcium chloride and similar materials may be added to concrete to speed up setting. Before you install aluminum conduit, find out if chlorides will be used in the concrete. Check with the authority having jurisdiction. A better rule of thumb is to just go ahead and coat it with some kind of tar coating, like a cold tar, cold pitch. Just paint it the entire length of the conduit, and that will prevent it from oxidizing. 1.1.5, identifying black enamel steel conduit. Rigid black enamel steel conduit, often called black conduit, is steel conduit coated with black enamel. In the past, this type of conduit was used exclusively for indoor wiring. Black enamel steel conduit is no longer manufactured for sale in the United States. It's mentioned only because it may still be found in existing installations. 30 years, I don't think I've ever seen any black enamel pipe. 1.1.6, identifying intermediate metal conduit. IMC is a type of rigid steel conduit. It has a wall thickness less than that of rigid metal conduit, but greater than that of EMT. The weight of IMC is approximately 2/3 that of rigid metal conduit. Because of its lower purchase price, lighter weight, and thinner walls, intermediate metal conduit installations are generally less expensive than comparable rigid metal conduit installations. However, IMC installations still have high strength ratings. Additional information on IMC may be found in Article 342. The outside diameter of a given size of intermediate metal conduit is the same as that of comparable size rigid metal conduit. Therefore, rigid metal conduit fittings may be used with IMC. Because the threads on IMC and RMC are the same size, no special threading tools are needed to thread intermediate metal conduit. Some electricians feel that threading IMC is more difficult than threading RMC because IMC is somewhat harder. The internal diameter of a given size of IMC is somewhat larger than that of the same size RMC because the difference in wall thickness. Bending IMC requires special shoes to support the conduit so it does not collapse. Like rigid metal conduit, intermediate metal conduit is permitted to act as an equipment grounding conductor as defined in section 250.118A3. However, the use of IMC may be restricted in some jurisdictions. It's important to investigate the requirements of each authority having jurisdiction before you select any materials. 1.1.7, identifying rigid polyvinyl chloride. This is PVC pipe. You have different schedules, meaning different thicknesses. You have Schedule 40, Schedule 80. If you're burying it, if it's for the power company, they want a minimum of Schedule 80. If you're using it for surface entrance conductors on a job, you want Schedule 80. If you're using it on a job in walls to extend circuits, Schedule 40 is sufficient. We do not use Schedule 20, it's too thin. That's like sprinkler pipe. The people who install sprinklers will use a Schedule 20. And you can pretty much break it with your hand. They're very thin. This is highlighted. PVC is non-corrosive, chemically inert, and non-aging. It's often used for installation in wet or corrosive areas. PVC does not have the same corrosion problems as steel and aluminum. However, it may deteriorate under some conditions such as extreme sunlight. PVC is marked according to standards set by the National Electrical Manufacturers Association, or UL Solutions, formerly known as Underwriters Laboratory, as shown in Figure 5. Note that the PVC in the figure is marked as sunlight resistant. Okay, here's PVC conduit, sunlight resistant. And it's 1.5 inch trade size. And does it tell us the schedule? It should. Nonmetallic conduit. I don't see it. I don't see it. It should tell us Schedule 40 or Schedule 80. All right. Since PVC is lighter than steel or aluminum, rigid metal conduit, IMC or EMT, it is considered easier to handle. PVC can usually be installed much faster than other types of conduit because the joints are made with cement and require no threading. Here's a highlight. PVC contains no metal. This characteristic reduces the voltage drop of conductors carrying alternating current in PVC compared to identical conductors in steel conduit. Because PVC is non-conducting, it cannot be used as an equipment grounding conductor. An equipment grounding conductor sized in accordance with Table 25122 must be pulled in each PVC conductor run, except for underground surface entrance conductors. PVC is available in a variety of lengths. Some areas require to be cut to 10 feet prior to installation. PVC is subject to expansion and contraction related to the difference in temperature, plus any radiating effects on the conduit. So you'd have to put an expansion joint. This is a highlight. In moderate climates, even a 10-foot installation of PVC would require an expansion joint per the National Electrical Code. Here's another highlight. It says PVC is affected by higher than usual ambient temperatures. To avoid damage to PVC caused by temperature changes, expansion couplings are used. Okay, so here's a telescoping expansion coupling. It allows the pipe to move in and out without damage to the pipe. These are PVC conduit bodies. Here's a PVC box. Here's a male adapter and a female adapter. Here's a flexible 90. You can do a 0 to 90 degrees flexible elbow. Here's a 90, here's a 45. Here's a highlight. It says Schedule 80, extra heavy wall for direct burial in the earth, above ground installations for general applications, and installations where the conduit is subject to physical damage. Schedule 40 heavy wall is for direct burial in the earth and above ground installations, but the Schedule 80 is better. It's thicker. Like I say, we do not use Schedule 20. So it says some regulations for maximum spacing of supports, 1/2 inch to 1 inch conduit, or PVC, is every 3 feet, 1.25 to 2 inches every 5, 2.5 to 3 is every 6, and 3.5 to 5 is every 7 feet. 6-inch conduit is every 8 feet. 1 point. All right, let's take a look at polyvinyl chloride in the code book, PVC, Article 352. 352 rigid polyvinyl chloride conduit. This article covers the use, installation, and construction specifications for rigid polyvinyl chloride conduit and associated fittings. So use is permitted. The use of PVC shall be permitted in accordance with 352.10A through K. Concealed, encased in concrete, corrosive influences, in cinders, wet locations, dry and damp locations, exposed, underground installations, support of conduit bodies, and installation temperature limitations and physical damage. So it's a very versatile conduit. It can be used in a lot of different places. The uses not permitted are hazardous locations, and any hazardous specified location except as permitted by other articles of this code. So it may be permitted depending on what the other articles in the code book say. Support of luminaires for the support of luminaires or other equipment not described in 352.10I. So you can't use it to support luminaires. You have to use rigid metal conduit for that. Physical damage, where subject to physical damage except as permitted in 352.10K. Ambient temperatures, where subject to ambient temperatures in excess of 122 degrees Fahrenheit, unless listed otherwise. So all of these actually have exceptions. In theaters and similar locations. In theaters and similar locations except as provided in 518.4 and 520.5. So the minimum size of PVC is 1/2 inch. The maximum size is 6-inch trade size. The number of conductors is governed by Table 1 in Chapter 9 of the NEC. Bends, how made? Bends shall be made so that the conduit will not be damaged and the internal diameter of the conduit will not be effectively reduced. Field bends shall be made only with identified bending equipment. Radius of the curve of the center line of the conduit shall not be less than that shown in Table 2, Chapter 10. The number of bends in one run, the total degree of bend in any conduit run shall not exceed 360 degrees between pool points. So if you need more degree than that, then you just put a pool box. Securely fastened. PVC conduit shall be securely fastened within 3 feet of each outlet junction box, device box, conduit body, or other conduit termination. Conduit listed for securing at other than 3-foot intervals shall be permitted to be installed in accordance with the listing. And here's their Table 352.30B, support of rigid polyvinyl chloride conduit. So 1/2 and 1-inch conduit needs to be secured every 3 feet. 1 1/4 to 2 inches every 5 feet. 2 1/2 to 3 is 6 feet. 3 1/2 inch to 5 inch or 7 feet. And 6-inch PVC can be supported every 8 feet. It has the characteristic that it will expand and contract with the weather. So you have to have expansion joints. You have to take that into consideration. They tell you the length of change for how many degrees of temperature change. What else does it say? Splices and taps. Splices and taps shall be made in accordance with 300.15. That says they have to be contained in a box. You can't splice or tap inside of the conduit. And marking. All right. The rest of this you can read on your own. If there's a need for it, look it up in your code book. Let's get back to the book. 1.1.8, identifying high-density polyethylene conduit. High-density polyethylene conduit, HDPE, is a rigid non-metallic conduit listed for underground installations. It's suitable for direct burial or where encased in concrete. In many signaling and communications applications, it comes on reels with conductors pre-installed and may be laid in a trench or plowed into the earth. It's not listed for above ground use unless encased in 2 inches of concrete. So high density polyethylene, HDPE. 1.1.9, identifying liquid-tight, flexible, non-metallic conduit. Now we're going to be using this term flexible. Flexible means it can be bent by hand and it can be returned to its former position. So if I have a flexible conduit, flexible metal conduit, flexible nonmetallic conduit, liquid tight flexible metal conduit, liquid tight flexible nonmetallic conduit, let me see if I can get my hands in here. It can be bent by hand, and you can always put it back straight. If you have a shower head spray nozzle in your shower at home or at your kitchen sink, if you have a spray nozzle that you can remove from the faucet and you can move it around and spray, that's a very good example of what flexible metal conduit looks like. It's an aluminum spiral wrap raceway with wires inside of it, and it can be moved. Like I say, it can be bent by hand. That's the definition of flexible, able to be bent by hand. So Liquidtight flexible non-metallic conduit was developed as a raceway for industrial equipment. It protects conductors from vapors, liquids, and solids. In some cases, the NEC allows Liquidtight flexible non-metallic conduit for outside and direct burial usage. The last bit of raceway before you hook up to a motor will be some type of flexible raceway because motors vibrate. So because of the vibration, you're going to put some kind of a flexible conduit, either flexible metal conduit if it's indoors, liquid tight flexible metal conduit if it's outdoors. Air conditioning systems a lot of times use liquid tight flexible non-metallic conduit. There's no metal inside of it. So liquid tight flexible non-metallic conduit, Article 356. Liquid tight flexible non-metallic conduit, Article 356. Let's take a look. Article 356, liquid tight flexible non-metallic conduit. This article covers the use, installation, and construction specifications for liquid tight flexible non-metallic conduit and associated fittings. Use is permitted where flexibility is required for installation, operation, or maintenance, where protection of the contained conductors is required from vapors, machine oils, liquids, or solids, for outdoor locations where listed and marked as suitable for the purpose, for direct burial where listed and marked for the purpose, installed in lengths longer than 6 feet where secured in accordance with 356.30, liquid tight flexible non-metallic conduit as a listed manufactured pre-wired assembly, metric designator 16 through 27 or trade size 1/2 inch through 1 inch conduit. For encasement in concrete where listed for direct burial and installed in compliance with 356.42. So also in locations subject to severe corrosive influences as covered in 300.6 and where subject to chemicals for which the materials are specifically approved. Conductors or cables rated at temperatures higher than the listed temperature rating for liquid tight flexible non-metallic conduit shall be permitted to be installed in liquid tight flexible non-metallic conduit, provided the conductors for cables are not operated at temperature higher than the listed temperature rating of the liquid tight flexible non-metallic conduit. Use is not permitted where subject to physical damage, where any combination of ambient and conductor temperatures in excess of that for which it's listed, in lengths longer than 6 feet except as permitted by 356.10.5, or where longer lengths is approved by as an essential for the required degree of flexibility, in any hazardous location except as permitted in other articles of this code. So the minimum size is 1/2 inch. It shall not be used unless permitted for metric designators, trade size 3/8 as follows. For enclosing the leads of motors as permitted in 430.245B, in lengths not exceeding 6 feet as part of the listed assembly for tap connections to luminaires as required in 410.117C. The maximum size is 4. So basically from 1/2 inch to 4 trade size, you can use 3/8 in special conditions, in exceptions. Number of conductors. The number of conductors shall not exceed that permitted by the percentage fill specified in Table 1 of Chapter 9. Bends how made? Bends in conduit shall be so made so that the conduit is not damaged and the internal diameter of the conduit is not effectively reduced. Bends shall be permitted to be made manually without auxiliary equipment. The radius of the curve of the center line of any bend shall not be less than that shown in Table 2, Chapter 9. Number in one run, the total degrees of bends in the conduit run shall not exceed 360 degrees between pull points. So if you need more, you're going to have to add a pull box. All cut ends of the conduit shall be trimmed inside and out to remove any rough edges. Let's see, what else do they say here? Where installed in lengths exceeding 6 feet, the conduit shall be securely fastened at intervals not exceeding 3 feet and within 12 inches on each side of every outlet box, junction box, cabinet, or fitting. Where used, cable ties shall be listed for the application and for securing and supporting. Let's see, horizontal runs of Liquidtight flexible non-metallic conduit supported by openings through framing members at intervals not exceeding 3 feet and securely fastened within 12 inches of the termination point shall be permitted. So you can run them between studs and you don't have to secure them to each stud. You just have to secure it within 12 inches of the box. Let's see, construction specifications says Liquidtight flexible non-metallic conduit as a pre-wired manufactured assembly shall be provided in continuous lengths capable of being shipped in a coil, reel, or carton without damage. And they have to be marked every 2 feet in accordance with 110.21. Okay. That's electrometallic tubing. Product information. This type is commonly referred to as hose. It consists of an inner and outer layer of neoprene with a nylon reinforcing web between the layers. Liquidtight flexible non-metallic conduit type B is the most widely used. It consists of a smooth wall flexible PVC with a rigid PVC integral reinforcement rod. If you've got a sharp pocket knife, you can cut through this with your pocket knife. Just don't get hurt. Don't cut through it and end up cutting your arm. Liquidtight flexible non-metallic conduit is sunlight resistant and suitable for use at conduit temperatures of 176 degrees Fahrenheit when dry and 140 degrees Fahrenheit when wet. It's available in sizes 3/8 through 4 inch. Metric designator 12 through 103. Section 356.12 states that Liquidtight flexible non-metallic conduit cannot be used where subject to physical damage. Liquidtight flexible non-metallic conduit is also limited in lengths no longer than 6 feet, except where properly secured, where flexibility is required, or as permitted by NEC Section 356.10. And of course, because it's non-metallic, you must pull an equipment grounding conductor inside internally. So here are fittings. They have a 90-degree fitting and a 45-degree fitting and a straight fitting for Liquidtight flexible connectors. 1.1.10, identifying flexible metal conduit. This is highlighted. Flexible metal conduit, FMC, called Flex, is generally available in 2 types, non-Liquidtight and Liquidtight. Flexible metal conduit may be used for many types of wiring systems. Code related to flexible metal conduit is covered in Article 348. Liquidtight flexible metal conduit is covered in Article 350. So I have non-Liquidtight and Liquidtight. The difference between the two, the Liquidtight is the same as the non-Liquidtight. It's just flexible metal conduit, but they've put a rubberized coating on the outside of it the entire length of the conduit. That rubberized coating, very similar to the PVC coating on the Robberoy, the rigid conduit with the PVC coating. It's very similar to that. It's flexible. You can cut it with your pocket knife, but it makes that conduit liquid tight. It keeps rain from getting inside of it. Flexible metal conduit is 348. Liquidtight flexible metal conduit is 350. Flexible metal conduit is made from a single strip of steel or aluminum wound and interlocked. Flexible metal conduit is typically available in diameters from 3/8 of an inch to 4 inch, and metric designator from 12 to 103. Here's a highlight. Flexible metal conduit is often used to connect equipment or machines that vibrate or move slightly during operation. Flexibility. Here's another highlight. NEC Article 348.24b. It should not be bent more than the equivalent of 4/4 bends, 360 degrees total, between pull points. Example, conduit bodies and boxes. So you should not bend flexible metal conduit more than 360 degrees unless you put a box and then you can continue running it. Usually you won't have that kind of count of bends. The flexible metal conduit and Liquidtight flexible metal conduit, like I say, are usually used in pieces that are 6 feet or shorter, and it's just to connect to something that vibrates. It can be connected to boxes with a flexible conduit connector and to rigid metal conduit or EMT using a combination coupling. Flexible to rigid combination coupling is shown in figure 9. So here is a flex to rigid connector. You could screw the rigid conduit or the EMT into this side, and then the flexible conduit can be secured with this clamp. As you tighten the screw down, this arm will actually move in and tighten the collar around the base of the flexible conduit. Flexible metal conduit is Article 348 in the NEC. Let's take a look at that now. Here's Article 348, flexible metal conduit. This article covers the use, installation, and construction specifications for flexible metal conduit and associated fittings. Use is permitted. Flexible metal conduit shall not be used in the following: in wet locations, in hoistways other than permitted in 620.21a1, in storage battery rooms, in any hazardous locations except as permitted by other articles of this code, where exposed to materials having a deteriorating effect on the installed conductors such as oil or gasoline. Underground or embedded in poured concrete or aggregate, where subject to physical damage. The size, the smallest size is 1/2 inch. You are allowed to use size 3/8 for enclosing the leads of motors. It says for enclosing leads of motors as permitted in 430.245b, and lengths not to exceed 6 feet for any of the following uses: for utilization equipment as part of the listed assembly, for tap connections to luminaires as permitted in 410.117c, for manufactured wiring systems as permitted in 604.100a, and hoistways as permitted in 620.21a1, and as part of a listed assembly to connect wired luminaires sections as permitted in 410.137c. The maximum size is size 4-inch designator. Number of conductors, well, that's covered by Table 1 in Chapter 9. Bends, how made? Bends in conduit shall be made so that the conduit is not damaged and the internal diameter of the conduit is not effectively reduced. Bends shall be permitted to be made manually without auxiliary equipment. The radius of the curve of the center line of any conduit shall be not less than that shown in Table 2, Chapter 9. And number of in one run, the total degrees of bend in the one conduit run shall not exceed 360 degrees between pull points. Securely fastened. Flexible metal conduit shall be securely fastened and placed by an approved means within 12 inches of each box, cabinet, conduit body, or other conduit termination, and shall be supported and secured at intervals not exceeding 4.5 feet. Where used, cable ties shall be listed and be identified for securement and support. There are a couple of exceptions to the rules. Where a flexible metal conduit is fished between access points through concealed spaces in finished buildings or structures, and supporting is impractical. So if you're using flexible metal conduit to feed, let's say you're putting in a new receptacle and that receptacle is 18 inches off the above finished floor, you're going to fish in at least 7 feet of flexible metal conduit from the attic. You need not secure it in the wall. There's no way to get to it without taking the drywall off, so you don't need to do that. That exception tells you you don't have to secure it every 4.5 feet. Where flexibility is necessary after installation, lengths from the last point where the raceway is securely fastened shall not exceed the following: 3 feet for trade sizes 1/2 through 1 1/4, 4 feet for trade sizes 1.5 through 2 inch, and 5 feet for trade sizes 2.5 inches and larger. Lengths not exceeding 6 feet from a luminaire termination connection for tap connectors, connections to luminaires as permitted in 410.117C. Supports horizontal runs of flexible metal conduit supported by openings through framing members at intervals not greater than 4.5 feet and securely fastened within 12 inches of termination points shall be permitted. Let's see, grounding and bonding. Okay. Flexible metal conduit shall be permitted to be used as an equipment grounding conductor when installed in accordance with 250.118A5, where flexibility is not required after installation. Flexible installations and equipment grounding conductor shall be installed where flexibility is necessary to minimize the transmission of vibration from equipment or to provide flexibility for equipment that requires movement after installation. So if you're using this flexible metal conduit in length 6 feet or less, and you're using it as a motor lead because the motor vibrates and you need flexibility, you must pull an equipment grounding conductor in that flexible metal conduit. Equipment grounding conductors, where required or installed, equipment grounding conductors shall be installed in accordance with 250.134. Bonding jumpers were required or installed. Equipment bonding jumpers shall be installed in accordance with 250.102. Okay. All right, very good. We'll go back to the book. Liquidtight flexible metal conduit has an outer covering of Liquidtight sunlight resistant flexible material that acts as a moisture seal. It's intended for use in wet locations. It's typically used with equipment and motor connections when movement of the equipment is likely to occur. Vibration. The number of bends, size, and support requirements for Liquidtight conduit are the same for all flexible conduit. Fittings used with Liquidtight flexible metal conduit must also be of the Liquidtight type. Let's see here. It says the following are some of the support requirements. Straps or other means of securing flexible metal conduit must be spaced every 4.5 feet within 12 inches of each end. At terminals where flexibility is necessary, longer lengths are permitted per section 348.30 and the exceptions in section 350.30. For example, where flexibility is required for conduit sizes 1/2 inch through 1 1/4, metric designator 16 through 35, lengths of up to 36 inch without support are permitted. That should probably be a highlight. 1.2.0, bonding conduit. For safety, most equipment that receives electrical power and has metal frame is bonded. This is done by making an electrical connection from the metal frame to the grounding point at the service entrance equipment. The purpose of the equipment grounding conductor is to provide a low resistance path to ground for all equipment that receives power. This is done so that if an ungrounded conductor comes into contact with the frame of the equipment or piece, the circuit overcurrent device immediately opens the circuit. It also reduces the voltage to ground that would be present on the fault equipment if a person came into contact with the equipment frame. The equipment frame is connected to a wire, the equipment grounding conductor. The wire is directly connected to the ground point at the grounding terminal. The equipment frame is connected to a metal conduit or other type of raceway system. This provides an uninterrupted and low impedance circuit to the ground point at the service entrance equipment. The metal raceway or conduit acts as the equipment grounding conductor. According to NEC section 250.96, metal raceways, cable trays, cable armor, cable sheaths, enclosures, frames, fittings, and other metal non-current carrying parts that are to serve as equipment grounding conductors with or without the use of supplementary equipment grounding conductors shall be bonded where necessary. This ensures electrical continuity and safely conducts any fault current likely to be imposed on them. Any non-conductive paint, enamel, or similar coating shall be removed at threads, contact points, and contact surfaces, or be connected by fittings determined to make such removal unnecessary. Let's take a look for a second